Here we will see a technique that works for integrals that contain a square minus u square, a square plus u square, and u square minus a square contained inside a radical. It eliminates square roots, where a is a constant. 1. For integrals involving root a square minus u square, let u equal a sin zeta. Second, for integral involving root a square plus u square, let u equal a tangent zeta. Third, for integrals involving root u square minus a square, let u equal a secant zeta. Now let's see an example. Example 1. Evaluate the following integral. Integral a divided by x fourth root 9 minus x squared dx. Root 9 minus x squared is in the root a squared minus u squared, where a equals 3. X equals 3 sine x, dx equals 3 cosine x dx. With a substitution on the square roots is a minus x squared equals 3 root 1 minus sin zeta square equals 3 root cosine zeta square equals 3 absolute cosine zeta. Integral 1 divided by x fourth root 9 minus x squared dx equals integral 1 divided by 81 sine zeta fourth 3 cosine zeta times 3 cosine zeta d zeta. 1 divided by 81 integral 1 divided by sine zeta fourth d zeta equals 1/81 integral cosecant zeta fourth d zeta equal 1/81 integral cosecant zeta square times cosecant zeta square d zeta equals 1/81 integral cotangent zeta square plus 1 cosecant zeta square. We use u equals cotangent zeta, so that du equals cosecant zeta square d zeta. D zeta equals du divided by negative cosecant zeta square. Then negative 1/81 integral u square plus 1 cosecant zeta square times du divided by cosecant zeta square equals negative 1/81 1/3 cotangent zeta cube plus cotangent zeta plus c. Now we draw a triangle. Sine zeta equals x divided by 3. Cotangent zeta equals root 9 minus x squared divided by x. Let's go back. The original formula equals negative 1 divided by 81 times 1/3 negative root 9 minus x squared divided by x cubic minus root 9 minus x squared divided by x plus c. Finally, the answer is showed.
So here for example 2, we're finding the integral of radical negative x squared plus 6x minus 5 d of x. And off to the side, we should rewrite whatever's inside the radical into the format we need it to be. So we will get negative x squared plus 6x minus 5 will equal negative x squared minus 6x plus 9 minus 5 plus 9, which will give us 4 minus x minus 3 squared. So after getting that format that we need, we should put it back inside the original integral, which will give us the integral of radical 4 minus x minus 3 3x dx. And then we should substitute the x minus 3 equals to 2 sine x and solve for x. So we get x equals 2 sine theta plus 3. And then the derivative of that will be d of x equals 2 cosine theta d theta. And off to the side here, we can simplify the radical 4 minus x minus 3 squared, which will equal 2 cosine theta. So after that, we can put it all back into our integral, which will be the integral of 2 cosine theta times 2 cosine theta d theta. When we simplify that, we get 4, the integral of cosine squared theta d theta. And then afterwards, we can use one of the identity rules to make it 4 times 1/2 the integral of 1 plus cosine 2 theta d theta. And afterwards, we find the integral of that, which we will get 2 times theta plus 1/2 sine 2 theta. And afterwards, we can multiply the 2 out to everything inside the parentheses, so we will get 2 theta plus sine 2 theta. And after further simplifying, we get 2 theta plus 2 sine theta times cosine theta. So now we have to find out whatever the theta is, the sine theta, as well as the cosine theta. So off to the side here, we can draw a triangle again. And we can get that the opposite will be x minus 3, the hypotenuse will equal 2, and the adjacent will equal to radical negative x squared plus 6x minus 5. So we can find out that theta will equal arc sine of x minus 3 over 2, so we can plug that one in. And afterwards, we can find out that cosine theta will equal x minus 3 over 2, and then cosine theta will be radical negative x squared plus 6x minus 5 over 2. So after simplifying everything, our final answer will be 2 arc sine of x minus 3 over 2 plus x minus 3 over 2 times negative x squared plus 6x minus 5 plus c. And over here, for our third example, we have to evaluate the integral of x cubed over radical x squared plus 4 dx. So then here off to the side, we can substitute x equals 2 tangent theta, and after that we define the derivative once again, which will be dx equals 2 secant squared theta d theta. And also, using our rules, we can simplify the radical x squared plus 4 to equal 2 secant theta, but of course we have to change it back later. So after plugging everything in, we get the integral of 2 tangent theta quantity cubed over 2 secant theta times 2 secant squared theta d theta. So we can cancel out the 2 secant and 1 on both top and bottom, which will result in the integral of 8 tangent cubed theta times secant theta d theta. And then after that, we can use the identity rule of tangent squared x plus 1 equals secant squared theta. So we get the integral of 8 times secant squared theta minus 1 times secant theta times tan theta d theta. And after that, we can use u substitution. We can set u equals to secant theta, and then we find the derivative of that, which will equal du equals secant theta tan theta d theta. So we have to bring d theta to one side. That will equal to du over secant theta tangent theta. So after plugging that all in, the secant theta and tangent theta will cancel out, and then we will get the integral of 8 times u squared minus 1 of d of u. And after that, we can distribute the 8 over, and we will get the integral of 8u squared minus 8 times du. And after that, we will get 8 over 3 u cubed minus 8u. And after that, we have to substitute back in where we sub in for u in. So we get 8 over 3 secant cubed theta minus 8 secant theta. So now we have to draw the triangle once again and find out whatever secant theta is. So we know that tangent theta equals x over 2, which means that x will be on the opposite, 2 will be adjacent, and our hypotenuse will be radical x squared plus 4. So we know that secant theta will equal radical x squared plus 4 over 2. So after that, we can plug it back into the 8 over 3 secant cubed theta minus 8 secant theta. And we will get 8 over 3 times radical x squared plus 4 over 2 cubed minus 4 times radical x squared plus 4 over 2. And then after we simplify that, we get our final answer, which will be x cubed plus 4 to the power 3 over 2 over 3 minus 4 rad x squared plus 4 plus c at the end. So here on example 4, we have to use what we previously learned to show that the area of a circle of radius r is given by a equals pi r squared. So first off, we can start by graphing it, and we can find out that the arc here is equal to radical r squared minus x squared. So we can set the area equals to 4 integral of 0 to r of radical r squared minus x squared dx. And off to the side, we can say that we can set x equal to r sine theta, and finding the derivative of that, we will get r cosine theta d theta. And then after plugging everything in, we will get 4, the integral from x equals 0 to x equals r of radical r squared minus r sine theta squared times whatever dx was, which we found, which is r cosine theta d theta. And then after simplifying it, and we can also take r outside of the integral because r is a constant in this case, we will get 4r squared, the integral of x minus 0 to x minus r of cosine squared theta d theta. And then we will get a equals 4r squared of the integral from x equals 0 to x equals r, 1/2 times 1 plus cosine 2 theta d theta. And after solving for the integral, we will get a equals 2r times theta plus 1 over 2 sine 2 theta, and then we solve it from x equals 0 to x equals r. So we could also further simplify it, making it equal to 2r squared times theta plus sine theta cosine theta from x equals 0 to x equals r. And now we can finally sub in the x equals r and x equals 0 into the thetas, which we will get 2r squared times arc sine of x over 2 plus x over r times radical x squared minus r squared over r from 0 to r. And we got those from drawing a triangle once again and finding everything out. And that will result us to equal 2r squared times pi over 2, which when we simplify it will indeed give us pi r squared, which is what we needed to find and prove that the area of a circle is pi r squared.
Example 5, integral 9 minus 4x squared root dx. It's a square minus u square form, so 2x equals 3 sin zeta, 2 dx equals 3 cosine zeta d zeta. So the original function equals 3 square minus 2x square root dx equals integral 3 square minus 3 sine zeta square root times 3/2 cosine zeta d zeta equals 9 divided 2 integral cosine zeta times cosine zeta d zeta equals 9/2 integral 1/2 zeta plus 1/2 sine 2 zeta plus c. As we all know, sin 2 zeta equal to cosine zeta sine zeta. So the original function equal 9/4 times zeta plus sine zeta cosine zeta plus c equals 9/4. We draw a triangle, and we know the zeta and 2x. We know the other one is 9 minus 4x square root. So the original function equals 9/4 x sine 2x third plus 2x times 9 minus 4x square root divided by 3 times 3 plus c. Example 6. Negative e2x divided e to 2x minus 1 to 3 half times dx is a u square minus a square form, so e2x equals second zeta. e2x dx equals second zeta tangent zeta d zeta. So the original function equals integral -1 divided second zeta square minus 1 to 3 half times second zeta d zeta tangent zeta equals integral negative second zeta tangent zeta divided tangent zeta cube d zeta equals negative integral 1 divided cosine zeta times cosine zeta square divided sine zeta square d zeta equals negative integral cosine zeta divided sine zeta square d zeta. We use a u here. U equals sine zeta, so du equals cosine zeta d zeta. Thus, the original function equals negative integral 1 divided by u squared du equals 1 divided by u plus c equals 1 divided sine zeta plus c. So now we need to find sine zeta. Now we draw a picture. We got zeta e to x 1, so the third is e 2x minus 1 root. So the original function equals 1 divided e to 2x minus 1 root plus c.
So here, for example 7, the integral of 1 over x squared times radical 9x squared minus 16. So just looking at the denominator of the radical 9x squared minus 16, we can set 3x equal to 4 secant theta. And then finding the derivative of that, we can get 3x dx equals 4 secant theta tan theta d theta. So we can then put it into our integral. So it'll be integral of 1 over x squared times radical 3x squared minus 16. And that will give us the integral of 1 over 4 over 3 secant squared theta times radical 4 secant theta squared minus 4 times 4 over 3 secant theta tan theta d theta. And that will give us 3 over 16 integral of secant theta tan theta over secant squared theta tan theta d theta. And after simplifying everything, we will get 3 over 16 integral of cosine theta d theta. Now we can finally solve for the integral, which we will get 3 over 16 sine theta plus c. So off to the side here on the left, we can draw a triangle and find out whatever sine theta is. So the opposite will be radical 9x squared minus 16. The adjacent will be 4, and the hypotenuse will be 3x. So after plugging everything in, we will get 3 times radical 9x squared minus 16 over 16 times 3x plus c. Don't forget the c.